Hi, this is Calvin Woolert with Solution Dynamics, and welcome to another part in the continuing video series on energy management best practices. Today we're going to talk about goal setting and some of the common mistakes companies often make when they set goals and what we feel is the proper way to set goals to avoid these mistakes. Common mistakes that are ubiquitous in manufacturing facilities are to A, set year-over-year cost reduction goals. And the reason that's a mistake is because you are inadvertently penalizing those plants for overachieving. So if a plant has an opportunity to reduce energy use by, say, 15% with a given project, but yet their goal is 2%, they will be hesitant to implement that project because in the following year, they will have already achieved more than they should have, and it's going to be very hard for them to reach their next year's goals because it's already been reduced by a significant amount. Another common mistake is basing goals on simple ratios and also doing improper due diligence when setting those goals initially for the organization. When it comes to goal setting, you want to look at both your energy use in terms of total as well as your energy use per unit of production, and understanding that Solution Dynamics is focused on manufacturing and industrial facilities. So production is a key metric when looking at energy use, or water use for that matter. So typically people will set goals either as just a total percent reduction or as a percent reduction per unit of production. That is a simple ratio goal, which is a common mistake. And this graph illustrates that. So what we have here is a graph that shows a scatter plot of actual data of energy use, in this case interruptible gas, expressed in kilowatt hours. Because it's an international firm, they use kilowatt hours instead of therms like we do here in the US, against production volume. And this could be tons or number of units. As you can see, this is a scatter plot that if you draw a line through it with some confidence bands around it, you get a line that hits the y-intercept at a level that is above zero. If you use a simple ratio, remember the equation of the line is y equals mx plus b. If you use a simple ratio, you're assuming b is actually zero. But the reality is that b is not zero. B is your base load, is your y-intercept. Here, as production goes down, you are hitting the y-intercept at just under 60,000 kilowatt hours. What that comes from is the base load within the facility. Things like lighting, which your lighting energy is not going to go up if you produce more units, or it's not going to go down if you produce less units. But as long as your plant is open and the lights are on, you're going to be using that energy, so it does not scale with production. The part that does scale with production is your slope, which is your m, y equals mx plus b. So the slope here expressed as alpha is the gradient, it's rise over run. That should scale, and a good indicator of the impact of production on your energy use is if you have a steep slope or a high slope. If your slope is relatively flat, that means your energy use really has very little correlation with the amount of production that you have. If you were to artificially set this base load to zero and your production goes up, you're assuming that this is a straight line to zero. If your production load goes up, your energy use is per unit, it'll look artificially better than it actually is. Because if it goes down, from looking at this graph, your energy use per unit would look worse. So in good times, it looks like you're doing really good against your goal. And when production goes down, it looks like you're doing horrible against your goal. That's because you haven't accurately set an equation which represents the energy use within your facility. And so that's why it's important to actually understand what that base load is and understand also what the production related load is. And then once you understand that, you can look at how energy is used in your facility. You can actually modify your base load through things such as lighting retrofits, like I mentioned, and reduce that amount, but you can also affect productivity related loads as well. We have a customer that set kind of a crazy goal where they were looking at doubling production while keeping the same energy use. And this brings into light the fact that there is this base load, because what happens if they double production? If they double production, this is what happens to their energy use. So assuming production is 100%, that means no change in production. Production is at 75%, they've reduced production by 25%, and so on. So as production goes up, you can look at what the expected energy use should be. So if their baseline energy use was 40% of their total energy use for a given production level, and they were to double their production, that means that their energy use per unit would have gone down by 20%. It takes some math to get to this, but this is a good indicator of the type of services that we provide during strategic planning, is to help companies understand what their goals mean and what kind of impact they have to do. So if you translate this into, okay, your goal is 200% production expansion, now what savings do I have to achieve in order to meet my goal? It is not 50% savings because you have this base load of impact. So if they have a base load energy consumption of 40% and they double production, that means they only have to achieve 30% savings in order to reach their goal. Thank you, and for more information, please contact us. The next videos in this series will be on KPIs and best practices.